So the technique we're going to use when we're dealing with the graphs and not just points is going to be, I usually call it a DNA chain because it's the closest thing I can sort of say that it looks like. For example, if I was to put more points in here, it kind of looks like a DNA strand. Maybe? Anybody? Kind of? Okay. Well, we can twist the graphs and make them look wonky and things and make it look more like a curve. You'll see what I mean, but I call it the DNA chain. And they still do this in grade 12 when you guys end up doing reflections in that class. But that's how I use the technique to tell me if this is my original graph here, this line y equals, what was it again, 2x minus 4, then by drawing the single line and the line y equals x and making a DNA chain, I'm going to be able to get the whole inverse graph on there. So we'll try one like that just to show you how the whole process goes. So again, if this is my graph square root of x, those of you that are sort of wondering, I believe this is the square root of x. Let me just make sure I haven't, maybe I've changed it slightly. Yes, I have. So at 4 it should be a 2. So I've done something to it, but it's some kind of square root graph here before I plotted it. But anyway, the point is that we don't need to know the exact graph to come up with its picture for the inverse. I'm going to start by drawing the line y equals x. Okay, so that's step number 1, is we're going to draw the line y equals x. And it's going to look something like this. And number 2 is to start making the DNA chain. Oops. Okay, so I'll show you how the DNA chain goes. I'll start drawing from this side to this side, like this. You know, the more points you want, the more accurate your graph is going to look. But let's just say that I start with something like this. Now, the job that you have to do is, this is only half of it, so you have to extend it and say, well, if that's how far it is to the function, it's also that far out to its inverse. It's also that far out to its inverse. So I'm trying to do the same length of line so that it's a reflection, and I'm going to the other side. So about like that. Okay, and now what this tells me, the blue part of it, gives me, let's do it in purple. The blue part of it tells me where the graph of the inverse is actually going to touch. So the graph on the inverse is going to be at these points here. Okay. So that gives me enough points that I can connect the dots. And that purple graph would be the inverse, the reflection on the line y equals x. So same distance at the other side of the line. Does that process kind of make sense? Okay, so let's try and construct our own reflection here for the next graph, which is, this would be some kind of cubic graph. See if you can construct what its inverse should look like. Okay, so let me try building this one for you. Let's see here. Again, we'll always start with that same point of reference, which is the line y equals x. So this is what I want before I start doing, let's see here. Before I start doing my lines, I need some reference, and that's what'll get me started. I also then need to make the distances. So the distance is always perpendicular, so you won't get a very good picture if you know, this is going to be not accurate if you do it vertical, right? You're trying to go distance, and we always measure distance perpendicular. So in this case, you're going to end up with the wrong picture. So make sure that when you do draw your lines, you want to try to do them perpendicular like this. So perpendicular, I'll try to go like this. One thing you'll notice if you practice this a bit more is you kind of get an idea for the curve a bit better. You won't need to draw as many points, but you know, it's certainly not going to be wrong to do more. That's not very perpendicular, why don't I? But it's certainly not going to be wrong to do more points just means that it's going to take us a little longer, but our picture will look better. Okay, so maybe that's what I'll start out with. Then to do the reflection, it has to be the same distance on the other side of the graph. So it's going to be like this. And then it's going to be like this. And if I connect the dots, it's going to something like this for my inverse. Okay. Does that picture resemble somewhat your picture? Can I just see by show of hands? Excellent. Okay, so we can move on from there. Let me just, yeah, this will be a good time